Hey everyone, and welcome. So today we're jumping into one of the most popular tools in machine learning, the decision tree. They're awesome, super easy to get your head around, but they have this one secret weakness, a tendency to be either way too right or, well, just way too wrong. It's what I call the Goldilocks problem. Let's get into it.
So think about this for a second. What if an algorithm could actually be too smart for its own good? I know, it sounds kind of weird, right? We're always trying to make our model smarter. But what happens when a model stops being just smart and turns into, I don't know, an obsessive perfectionist? That's the real challenge with decision trees. It's all about finding that perfect balance.
All right, so let's talk about the overachiever. See, decision trees are amazing because they basically build a flowchart from your data. They learn by making these simple yes or no splits. But here's the catch. If you just let one run wild, it'll just keep splitting and splitting and splitting. It'll try to learn every single tiny insignificant detail in the data it sees. It basically becomes a total overachiever.
And that overachieving, well, that leads to a huge problem we call overfitting. The best way to think about it is like this. Imagine a student who doesn't learn the textbook. They just memorize it. Every single word, every comma. If the exam asks questions pulled straight from the book, they'll get 100%. But what if you ask a question that's just a little bit different? One that requires them to actually understand the concept? They'd be totally stumped. That's overfitting. The model has memorized the noise, not the actual signal.
So what's actually going on here under the hood? Well, the tree just keeps growing deeper and deeper, getting more and more complex. It starts creating these crazy hyper-specific rules that might only apply to a single data point. You end up with these wild, jagged decision lines that perfectly snake around every single point in the training data, but they're completely useless when you show it something new. It can't generalize at all. Okay, so you're probably thinking, the solution's obvious. Just stop the tree from getting so complicated. And, you're right. But it's not that simple. Because if you pull back too hard, you run into the exact opposite problem. You can end up with an algorithm that's, well, just too simple. And this is what we call underfitting. So if overfitting was the student who memorized the whole book, underfitting is the student who just, glanced at the chapter summary 5 minutes before the exam. They haven't learned nearly enough to answer any of the questions right. The model is just too basic, and its predictions are going to be way off no matter what data you give it. And there it is. This is our Goldilocks problem right here. On one side, you've got overfitting. The porridge is too hot. The model is super complex, but it only works on the data it's already seen. Then, on the other side, you have underfitting. The porridge is too cold. The model is way too simple, and it's useless on all data. Obviously, neither of these is what we want. So, how do we find that sweet spot, the just right model? Well, the good news is we don't have to just close our eyes and hope for the best. We actually have tools, really powerful tools, to steer our decision tree away from those extremes and right into that perfect zone of balance. The way we do this is by tuning things called hyperparameters. The best way to picture these is like control knobs or dials on a machine. They're the settings that we get to tweak before we even start training the model. And these knobs give us control over how the model learns, and this is the key part, how complex we're going to let it get. Okay, so the biggest, most important dial on our dashboard is probably max depth. It's super intuitive. It literally just controls how deep the tree can grow, how many layers of questions it's allowed to ask. If you set max steps to a really small number, you get a short, simple tree, and you risk underfitting. But if you don't set a limit at all, you get this deep, gnarly, complex monster of a tree that is almost guaranteed to overfit. Let's just walk through a quick example. So say we start with max depth set to 1. The tree makes one single split. That's it. It's way too simple. Classic underfitting. Okay, scratch that. Let's try the other extreme. We let it grow as deep as it wants. Now it's a tangled mess. It's captured every single outlier, total overfitting. But what if we try something in the middle? Maybe we set max depth to, say, 5. And suddenly, boom, we've got a model that's complex enough to see the real patterns, but not so complex that it's just memorizing noise. It's just right.
Now, max depth is a huge one, probably our main go-to control knob.
But it is definitely not the only tool we have. Think of it like a whole dashboard full of dials we can tweak to get the model's behavior just right and stop it from going off the rails. So, what else have we got? Well, there's one called min samples split. This one basically tells the tree, hey, don't even bother trying to split a group of data unless it has at least, 10 data points in it. Or another one, min samples leaf, which makes sure every final answer, every leaf on the tree, is based on a decent number of examples. See? They're all just sensible rules to keep the tree from getting too carried away. So you see, the real goal isn't just to build the most complex model possible. Not at all. It's more of an art. It's about finding that optimal balance. It's about carefully tuning all these different dials to build a model that's powerful, yeah, but also practical. A model that has actually learned the pattern, not just memorized the past. And I'll just leave you with this one final thought. This whole balancing act, this constant push and pull between simple and complex, it's like the absolute core of machine learning. But it's not just about algorithms, is it? Think about it. In almost everything we do, managing a project, designing something, even just planning out your week, it's always about finding that just right balance. So where in your life are you looking for that Goldilocks zone? Something to think about. Thanks for tuning in.